Welcome back to The Talk Show. I'm your host. Before the break, we were talking to Beyonce and Arnold Schwarzenegger, who will be starring opposite each other in the upcoming rom-com. Our next guest needs no introduction. You may know him from his work as Frank in Godzilla 6, Godzilla vs. Devilzilla, or from his starring role as Frank in the YouTube Red series, Frank. Frank is now pivoting away from the big screen and focusing on his talent as a recording artist. Being shown for the first time, here is the music video for Frank's new single, Popular Calculus.
You try to understand calc, try to get cosine x. It is what it is, trying to figure out limits.
Fighting for your grades with a C in your test. Now you pull an all-nighter to attain a lane E.
It's turning to a mess, bringing out derivatives, cause I'm crying about my grades in popular calculus.
Said I'm crying cause of popular calculus.
My problem, I never understood math. I never liked big numbers. Now I'm dropping out of calculus. Learning equations is something I don't know of. I cry over numbers. Why can't I just love calculus? Calculus, I know how popular it is. It's not about having fun or feeling smart. It's only pain and misery. Calculus, I know how popular it is. And all that you have to do is be true to you, and all imposter syndrome win. Have fun, even if you fail your test today. Have fun, let's pray that the critic helps us stay. Talking about integrals and analyzing functions.
Can't understand a thing, especially with those markers.
I cried during classes and in between them.
Rethought my whole life while learning calc rules.
Calc helps me feel bad with the things it does. It ain't so funny talking about linear approximation and stuff. Ooh, finding errors cool, and everyone's understanding while I'm out there crying, dying. What are differentials?
That's the main part of the change in a function with respect to the independent variable.
Well, that's the only thing that I learned at school. My problem, I never understood math. I never liked big numbers. Now I'm dropping out of calculus. Learning equations is something I don't know of. I cry over numbers. Why can't I just love calculus? Calculus, I know how popular it is. It's not about having fun or feeling smart. It's only pain and misery. Calculus, I know how popular it is. And all that you have to do is be true to you, and all imposter syndrome win. Have fun, even if you fail your test today. Have fun, let's pray that the critic helps us stay. It's all you ever need to know. It's all you ever need. It's all you ever need to know. It's all you need to know. Calculus, I know how popular it is. It's not about having fun or feeling smart. It's only pain and misery. Calculus, I know how popular it is. And all that you have to do is be true to you, and all imposter syndrome win. Calculus, I know how popular it is. It's not about having fun or feeling smart. It's only pain and misery.
Wow. I now have the utmost pleasure of welcoming Frank Garcia on stage. Hey Frank.
Hi, host.
Thank you so much for being here.
Of course, thank you for having me.
Absolutely. So now, before we deep dive into popular calculus, I do want to just start by addressing the controversy surrounding the project. Popular Calculus has received critical acclaim for its innovative production, evocative lyrics, and of course the gorgeous vocals. However, your song has also been pretty widely panned by math teachers, number enjoyers, and even the National Association of Nerd Advocates, who released an official statement condemning the song for its unfavorable depiction of math, saying, and I quote, "This sucks." What do you think about the reaction you received after putting this out?
Well, host, thank you for having me and for giving me the chance to elaborate on this project. I conceived and wrote Popular Calculus at the time where I had the most hate for calculus in my heart. I was taking a calculus class and was struggling with many of the concepts, and in particularly frustrated with linear approximation and differentials. Like, we had literally just learned derivatives, and then we were having to add more into that, and like with a lot of other like concepts put together, I was like, I can't do this anymore. In my lit hum class, it was extremely different. You just read a book, try to learn a concept, and just write about it. But in calculus, it just never stopped. So I decided to express my anger towards calculus and how much I hated it with the combination of my musical talents, my beautiful voice, and of course, my personality throughout all of it. And so that's why I decided to write Popular Calculus.
Absolutely, yeah. Well, I think I speak for all of us when I say that I really connected with the message of your song. Calculus is frustrating, but from the sound of it, it seems like maybe you've mellowed out a little bit, maybe changed your tune a little bit. Have your thoughts on the subject changed at all since recording the song?
Yeah, they have drastically changed. I mean, I took calculus with my friend Squishy, and they were amazing at it. I could never compare to them, but they were able to help me understand a lot. And especially, I was really close with them at the time where we were learning about this concept of linear approximation and differentials. And well, yeah, they helped me understand it a lot, especially when
One day, I was walking down the street
I know how popular it is. It's not about having fun or feeling smart. It's only pain and misery. Calculus.
when I saw the finest person I've ever laid my eyes on sitting on a bench. I am very nonchalant and had to play it cool, so I kept walking past them. The only issue is that in my nonchalance, I forgot to remember any details about them that could have helped me figure out who they were. Well, I went out for that walk with Squeegee later that day and explained my predicament. I needed to find this person and ask them out, but I knew that it would be too hard without the help. Of course, Squeegee knew what to do instantly. She had me close my eyes and try to remember if there was anyone sitting around my mystery person. I thought really hard and realized that they were sitting next to Cheryl, who's in my PE class. So I went up to Cheryl and the next day and asked her who she was sitting next to on that bench and if I could have their number. Well, it turns out my mystery person is her mother, and she was not very pleased with me for asking, but that's besides the point. After I reported this all back to Squeegee, she giggled a little bit and then made an offhanded comment about how the situation was a lot like linear approximation.
I'm really bored right now.
anyways, Squeegee explained it like this.
Cheryl's mom is a point in a function. Let's just say the function is fx equals square root of x, where x represents every person I saw today. Fx represents the name of the person at the x value. Thinking about the function as a machine when you input an x value of a serial number of a person you've seen today. The output is the corresponding name of that person. So let's say we plot a point on the function. Mr. Man here was the fourth person I saw today. So this person equals x equals 4. If we enter 4 into our function, we find that the output will be the square root of 4, also known as 2. So the name of the fourth person I saw today is Mr. 2. Now, what if I wanted to find the identity of Cheryl's mom the same way? Let's say that Cheryl's mom was the 50th person I saw in a day. So Cheryl's mom equals x equals 50. Let's go ahead and try to figure out her name the way we did with Mr. 2. If we input x equals 50 into our function, we know our output will be the square root of 50, which would be equivalent to Cheryl's mom's name. The only issue is that the square root of 50 is a much harder value to calculate than the square root of 4. Now, in a perfect world, we'd have many resources we could use to identify this value. When I was walking by Cheryl and her mom, I could have easily found her identity if she were wearing, I don't know, maybe a name tag or a shirt with her name and a number on it. In a similar way, we could easily solve for the square root of 50 if we had a calculator, but we don't. So how did I figure out who Cheryl's mom was? Well, I used a point of reference that was close to her to better approximate who she was. That point of reference was Cheryl herself. Going back to the graph of the function, I'll place Cheryl right next to her mom. Let's say I laid my eyes on Cheryl before I looked at her mom. This would make her the 49th person I saw that day. So Cheryl equals x equals 49. Now, as I was walking by Cheryl and her mom, I found it much easier to identify Cheryl. If we input x equals 49 into our function, we see that the output is the square root of 49. Unlike the square root of 50, we know that the square root of 49 equals 7. So in this convoluted analogy, Cheryl's name is 7. We can now place Cheryl and her name next to her mom, just as it was in real life. Cheryl's known identity and her proximity to her mom were the keys to me figuring out who her mom even was. Cheryl allowed me to get closer to Cheryl's mom.
I'm still so bored right now.
Okay, well, we're gonna make this more mathy.
The first step is using calculus to approximate identity similar to the way I did in person is adding a line that runs tangent to x equals 49 on our function. The tangent line runs right through Cheryl, poor Cheryl. If you look closely at our function, we can see that the tangent line not only runs through x equals 49, but it also runs incredibly close to x equals 50. Since these 2 points are so close together on the function curve, the tangent line at the 2 points is also quite similar to each other. Host, I sense you might be coming to the same conclusion that I came when Squeegee explained this to me.
That this is stupid?
Not quite. The conclusion is that while the square root of 50 is an incredible hard value to calculate mentally, we can approximate this value by using our tangent line output at x equals 50. But for this, we'll need a formula.
You're making me hate calculus even more.
Well, here's our formula.
F of x is about f of a plus f prime a x minus a. F of x is our function here, the square root of x. F of a represents our known value on the function here, which that will be Cheryl, or x equals 49. And finally, our x value represents the value we are trying to identify, which would be Cheryl's mom, or x equals 50. Let's lay this out one more time. Here are all the pieces of our formula. F of x is equal to f of 49 plus the derivative of f of 49 times 50 minus 49. When we input that actual function, we see that the result is that f of x equals the square root of 49 plus 1 over 2 times the square root of 49. This is the derivative, plus 50 minus 49 simplifying. We see that f of x equals 7 plus 1 over 14. So Cheryl's mom, the square root of 50, is about 7 and 1 over 14. Just to check our work, we can calculate that 7 and 1 over 14, or 91 over 14, is equal to 7.07142, etc. The square root of 50 is equal to 7.07106, etc. When both are rounded, they both equal 7.071. You can see how close we're able to get the actual value of the square root of 50 with just linear approximation.
What were we talking about?
We just finished linear approximation.
Oh, okay. Well, I had a very similar experience actually when I was younger, but with differentials. Would you want to talk about those some more?
I didn't do none of that.
Okay, I'll do it. To learn about differentials, let's use the same function we've been working with. F of x equals square root of x. Point A represents the point on the tangent line, while a plus delta x represents another point on the function. The difference between these 2 points is called delta x, or the change in x between the 2 points. On the y-axis, we have f of a and f of a plus delta x. This line represents dx, or the run of the tangent line. This line represents dy, or the rise of the tangent line. As you can see, dx and delta x are equivalent here. However, this green line represents delta y, or the actual change in the output of 2 x values of the function. Unlike dx and delta x, dy and delta y are only approximately equivalent here. While the tangent line runs close to both a and a plus delta x, the y value of the tangent line at a plus delta x is slightly different than the y value of the function at a plus delta x. Differentials serve as a method of approximating how the output of a function changes when the input is changed slightly. This approximation is found by using the value of dy, since dy provides an estimation of delta y. Let's look at a practice function as a way to better understand how to calculate our differential. Suppose you have the function y equals 3x squared. Its derivative, dy dx, is 6x. Since we are looking to isolate dy, we can multiply both sides by dx. This leaves us with dy equals 6x times dx. More generally, this can be written as dy equals f prime of x dx. So, to put it all together, f prime of x dx is equivalent to approximately delta y. Let's do this one more time with a familiar situation. Here is x equals 49, and here is x equals 50. The difference between them, delta x, is 1. On the y-axis, we have y equals 7, the output of x equals 49, and f of 49 plus 1, the output of x equals 50. Using our formula, we get that dy equals f prime of 49 times 1. Simplified, dy equals 1 over 2 times the square root of 49, or 1 over 14. So the differential, or the approximate change in the output of our function from x equals 49 to x equals 50 is 1/14. If you recall from Frank's lesson in linear approximation, f of 49 is 7, while the approximation of f of 50 is 7 and 1/14. A change of 1/14, just like our differential. So yeah,
I know how popular it is. It's not about having fun or feeling smart. It's only pain and misery. Calculus, I know how popular it is. And all that you have to do is be true to you. And all imposter syndrome win. Have fun, even if you fail your test today. Have fun, let's pray Dr. Krichnik helps us stay.